We are about to see how ancient Egyptians built the pyramids using man-made stones which look exactly like natural rocks. The limestone blocks were cast on the site with a brilliant technology called irrational, recently rediscovered. The pyramids, some like this, huge and majestic. The most enduring were made from solid stones. Stones that conceal a secret thousands of years old. Incredible though it may seem, only now has anyone been able to solve the age-old mystery of these Egyptian stones. I'm Walter Broderick, one of a small team of independent researchers interested in some of the unsolved puzzles left by past civilizations. Right now we've been prying into the mystery of these Egyptian stones. People we find have long been mistaken about them. They have been led to believe that the pyramids were built in a manner which, when carefully examined, proves to be unfeasible. Generations of school children the world over have been asked to imagine vast teams of Egyptian slaves carving the stones, then hauling them to this pyramid site, and then hoisting them up until each one was placed in its exact position. But how could this have been done? The Great Pyramid of Cheops is comprised of about 2.5 million blocks. Most weigh 2 tons and could have been hauled by no less than 60 men. But some weigh up to 70 tons, and these are to be found not at the base of the pyramid, but some 40 meters high. Since the ancient Egyptians didn't have wheels or pulleys, they would have needed more than 2,000 men to haul each block. How could this have been done in just the 20-year reign of Pharaoh Cheops? To accomplish this task, at least 400 blocks per day would have had to be put in position as from the first day of the Pharaoh's accession to the throne. Hundreds of thousands of slaves would have been working simultaneously, squeezed shoulder to shoulder in the space of a single block in a modern city. But this would not have been feasible. In those conditions, the men would not have been able to budge. How then was the construction carried through?
How could they have cut these stones, which are extremely hard, with only the most primitive of tools? At best, they would have disposed of a copper saw, something like this. I don't seem to be getting very far.
And how was it possible to transport the large stones when the wheel had not been invented? and there were no pulleys to hoist them into the air. How could a civilization without hard metals carve the millions of blocks of the Great Pyramid to different and exactly calculated lengths in order to set them in patterns throughout the whole structure to eliminate the formation of vertical joints? The answer has at last been found. But before revealing the secret of how the pyramid blocks were cast on the spot, let us take a closer look at them. And above all, let us carefully examine those mysterious stones with which the pyramids were built.
This is the original entrance through the great enclosure wall that once completely surrounded the step pyramid here at Saqqara, thought to be the most ancient of all. In other words, here is where we can begin to study the techniques used in pyramid building, something which has puzzled men for centuries.
The pyramids of Egypt are concentrated in a relatively small area along the western side of the Nile. Mute witnesses to a bygone civilization, they rise up silently out of the desert sands. For thousands of years, many of them were buried under these sands and hidden from sight. It was only in the past 200 years or so that excavators began to uncover them. An initial examination of this long-lost culture was sparked off when Napoleon Bonaparte led an expedition to Egypt in 1798. His purpose was more than military. He took with him a large team of experts, geologists, mineralogists, naturalists and engineers, not to mention artists and engravers, who after many years of work produced an initial and impressive illustrated study of the Egyptian monuments. Thanks to Napoleon, it was the French who made the first serious inventory of the thousands of tombs and temples, as well as the vast burial grounds, the awe-inspiring Sphinx, and the giant pyramids of ancient Egypt. Work was carried on later by other Europeans, German and British scholars amongst others, and also by Americans. Archaeologists worked almost non-stop throughout the 19th and 20th centuries. The pyramids have been studied by each new generation of Egyptologists, scrutinized and examined over and over again for the light they have continued to shed on the early history and development of mankind.
Despite such long and exhaustive studies, many mysteries remained unsolved, and many queries until now had not been answered. The great question, to which nobody had found a convincing reply, is an apparently simple one. How were the pyramids built?
It seems strange that the most impressive of all these enormous man-made mountains was not one of the last to be constructed, but amongst the earliest. Stunning for its perfection and complexity of design, as well as for its gigantic proportions, it's almost as high as a 60-story building, the Great Pyramid of Cheops is located near the modern city of Cairo. As we have already said, Pharaoh Cheops, or Khufu as he was known in his lifetime, had the whole structure built during his reign, that is, in less than 20 years, early in the 3rd millennium BC, in other words, about 5,000 years ago.
The only pyramid to rival it as a feat of design and construction is this one. The first ever built, the step pyramid at Saqqara, erected just 100 years before the Great Pyramid. A vital clue as to how the Great Pyramid was built was present here all the time in the Step Pyramid, but was long overlooked by Egyptologists. They had been simply puzzled by the conundrum and unable to find a satisfactory answer. It seems they were not looking in the right place.
Those who examined the pyramid stones were archaeologists and historians, engineers and architects. It was only when these same stones were submitted to the analytical eye of a different type of scientist that they began to yield up their secret. The first man to posit a reasonable solution was Henri Le Chatelier, chemist, ceramist and metallurgist, born in France in 1850. In the early 20th century, he noticed that the famous statue of Pharaoh Khafra, or Khifrin, revealed no sign of tool marks, yet it had been made of diorite, the hardest type of stone, in a time when artisans possessed only simple stone or copper chisels. He concluded that with tools like these it would have been impossible to carve such a masterpiece. Le Chatelier suspected that it had not been carved at all, but made of agglomerated stone cast in moulds. So he began to examine other statues. He looked at ones that were apparently enamelled and cut thin sections of them with a diamond-tipped saw, and found that the enamel was not an applied coating, but part of the material from which the statue was made. He asserted that they were cast in some kind of synthetic material and not sculpted in natural stone. In much more recent times, another Frenchman, Dr. Joseph Davidovits, took up from where his predecessor had left off. Professor Davidovits is a scientist renowned for his research into a branch of chemistry whose chief study is geopolymers, natural materials made from compounded molecules at ambient temperatures. Throughout his long professional life, Professor Davidovits has taught in US universities, has published 2 important studies on the pyramids, and has patented a number of original products that employ sophisticated processes in the manufacture of cement. In 1998, Dr. Davidovits was awarded France's Chevalier de l'Ordre National du Mérite in recognition of his research and of his many patents for the production of cements. Following in Le Chatelier's footsteps and armed with his expert chemical knowledge on the subject of concrete and agglomerated stones, Davidovits began to take a deep interest in the material from which the original pyramids were built. How, he wondered, could the stones have been cut, and so perfectly cut, with the primitive tools available to those early Egyptian masons? At best, they disposed of no more than copper for sawing or chiselling, and copper is a softish metal of no use in hewing the hard limestone blocks from which the early pyramids are constructed. Professor Davidovits became convinced that a closer examination of the pyramid stones themselves might solve the riddle.
The professor seems to have been right. At all events, he found evidence to suggest that the limestone blocks were not cut stones at all. They were agglomerated artificial blocks that look exactly like natural ones.
The principal ingredient of the pyramid blocks is limestone, a sedimentary rock formed from skeletons and large fossils of marine organisms.
These fossil shells are normally found in sedimentary horizontal layers, yet in the stones of the pyramids at Giza, I found them in disarray, in all orientations, jumbled, as if they were artificially mixed with some kind of pestle in all directions. Another phenomenon I observed in the sample of the pyramid stone was the presence of air bubbles, organic fibers, perhaps hair, foreign materials not commonly found in natural limestone. These could be a proof that the stones were man-made. I also wanted to know the following. If the stones were carved, as most scholars believe, where were the fragments of broken stones left over? Limestone frequently splits on being cut. 20 million tons of limestone blocks must have produced millions of broken blocks and fragments. Yet not a trace of them has been found. Where are they?
To further confirm his suspicion that the pyramid stones were artificially made, Dr. Davidovits discovered an important clue not far from his own home, namely in the Louvre Gallery in Paris, where the irrational stele is preserved. This ancient stone inscription does not go back quite as far as the era when the Great Pyramid was built, but it is very old, some 4,000 years old.
This is the autobiographical funerary stele of a scribe and master craftsman called Ir-Tisen, who lived 2,000 years before Christ. He hints at a secret knowledge he possessed to fabricate stone statues, not by carving, but by casting them in a mold. Ir-Tisen states that he used a material mixture that hardened in the mold to reproduce any kind of object and figures, and that these objects and figures will withstand the fire and will not be destroyed by water. This suggests that Ir-Tisen worked with a chemically binding matter that could be mixed with certain types of mineral and poured into a mold to produce stone statues.
Professor Davidovits was now beginning to elaborate his thesis and was delighted to find this clue. With the enthusiastic approval of some distinguished Egyptologists, he produced his own new version of this ancient text, which represents the words of the master craftsman himself.
I know the secret of the hieroglyphs. I know the technique of molding fluid stone and of weighing according to the exact recipe. The making of molded parts that must be introduced inside and withdrawn after demolding, so that a member comes in its place. I know the going of a male figure and of a woman's, the instant of a realistic posture, the cringing of the solitary captive, the glance of the eye at its sister, the frightened face of a guarded foreigner, the balance of the arm of the one who overcomes the hippopotamus, the tread of the runner.
For Dr. Davidovits, however, this text, though highly significant, was only the beginning. Even more important data on agglomerating techniques was waiting to be deciphered on another ancient stele, which is found here on Sechel Island, on the great River Nile. Professor Davidovits would finally unravel the mystery by a careful and innovative reading of the hieroglyphs which are carved into the surface of this particular rock. This rock is known as the Famine Stele and stands to this day in its original site on Sechel Island in the midst of the great River Nile. Its text appears, as you can see, in hieroglyphs occupying 32 columns, which must be read from right to left. The first columns deal with the famine that occurred in the reign of Pharaoh Djoser around 3000 BC, in a period earlier than the reign of Cheops. The engraved hieroglyphs tell the following story. For years, the River Nile had periodically flooded its banks, watering the surrounding fields and making them apt for agriculture. In the reign of Djoser, however, the river did not rise. Hence, crops were unable to grow, the soil dried up and became sterile, and the result was a great famine throughout the land. Professor Davidovits was particularly interested, however, not so much in the historical passages on the flood, as in those which describe a chemical formula used in ancient times by a priest and sage, the great Imhotep, to fabricate an agglomerated block of stone. The stele text was originally deciphered in 1889, but due to the limitations of scientific knowledge at the time, that part containing the formula was misunderstood or not properly translated. Now Professor Davidovits, thanks to his chemical knowledge,
has been able to decode its true meaning.
In this section of the stele, which is known by the scholars as the Revelations of Imhotep, the most important word I deciphered and understood was the word arikat, a composite word made of two hieroglyphs which forms one single adjective. Ari is the past participle of a verb meaning to make, to fashion, and it is symbolized by an eye alongside a seated human figure which represents the man who does the work. The addition of a second word, kat, two hands held aloft, gives a new meaning, man-made. Arikat, therefore, means created by man. That is, when associated with minerals, something processed or synthetically made.
Professor Davidovits now felt sure his theory was right. The answer to the riddle of the pyramids lay in his particular branch of science, chemistry, or to give it the name of chemistry's ancient predecessor, alchemy. And the alchemist in question was the great Imhotep.
Chancellor and master architect of Pharaoh Djoser, he designed and built the step pyramid at Saqqara, the first manifestation of higher knowledge in ancient Egypt. Imhotep belonged to a closed organization of priests called the School of Mysteries of the Eye of Horus, exclusive guardians of knowledge in ancient Egypt. Imhotep, whose name means the sage who comes in peace, was revered in Egypt for 3,000 years. That is from his own lifetime during the reign of King Djoser, right up to the Greek and Roman conquests of Egypt. Imhotep's father was the royal architect, an hereditary noble who could decide his child's destiny. He chose to enroll the boy in the priesthood, and at a very early age, Imhotep's mother journeyed with her son down the Nile to install him in his new home at the temple of Anu. It was here, in this center of science and religion, in its great library, that Imhotep began to learn the meaning of symbols and was taught to read and write in hieroglyphic language. As time went by, he studied temple design, as well as building techniques, geometry, medicine, and everything that the wise priests had been able to fathom about the structure of the universe. At night, he learned to locate the Earth's position within the overall design of the constellations and to calculate time from a reading of the stars. His spiritual guide taught him the sacred meaning of the Egyptian deities, with their animal heads, each representing a universal quality accurately expressed by the animal, like the sharpness and vision of the hawk or the cunning of the fox. One day his mentor decided he had reached a degree of wisdom that merited his ascent to the second inner sanctum of the temple, where he was to begin his training in alchemy. Experienced alchemists worked here, melting stone to give shape to sacred vessels. The time had come for Imhotep to pay homage to the god Num, the giver of form and creator of men's bodies, to whom all sacred vessels were offered, and to swear that he would transmit only to his designated successor the secret chemical knowledge he was about to receive. A priest-scientist who could make stone vessels enjoyed a special status, since his revealed knowledge enabled him to give form to the eternal, and stone was a symbol of the eternal. He now belonged to the closed circle of those who had discovered the chemical uses of a transforming substance that was plentiful in Egypt, natron salt, a crystalline mineral which readily reacts with other minerals and most known substances.
Natron is a salt which mainly consists of sodium carbonate, which is found in very great quantities in Egypt, in the deserts, and especially in Wadi el Natron. The ancient Egyptian alchemists used it to catalyze different kinds of chemical reactions involving siliceous minerals. Natron used it to bake unleavened bread, which was the national food, and for mummification, since it preserves flesh long after vital functions had ended. Natron never lost its sacred value. In the Talmud, it symbolized the Torah, or the law, and in the Bible, it was the salt of the covenant between Yahweh and his chosen people.
Imhotep now learned of a second sacred substance, lime, the mineral which binds. He learned how to make lime by burning and reducing to ashes those sedimentary rocks such as limestone and dolomite which are formed out of the remains of marine organisms. The fire oxidizes and converts the rocks into a powdery residue, and that is lime. The ashes of plants are rich in lime, and the priests established the custom of receiving ashes from cooking fires from all over Egypt. Imhotep next discovered something quite extraordinary. Lime mixed with natron salt and water produced a third substance, a much more corrosive one, and sparked off a strong chemical reaction and transformed other materials. He had happened upon what we now know as caustic soda.
When Imhotep added natron and lime to a pool of water, a burning chemical reaction began. Natron dissolves in water, and then lime particles dispersed and went into suspension, forming caustic soda. Any siliceous minerals that has water in its amorphous structure reacts easily with caustic soda, forming sodium silicate, called soluble glass by the ancients. Soluble glass mixed with the blue minerals turquoise and chrysocolla produce a chemical reaction that gives form to a special binder, a water-resistant cement, used to mold in stone their vases and statuettes. This Egyptian cement is a powerful binder that integrates alumina and silica into a new composite, a synthetic zeolite mineral that looks exactly like a natural rock.
As we shall now see, it would not be long before the Egyptian priests had taken this technique to its logical conclusion by producing not little images, but huge artificial mountains of stone. We have been talking about the ancient priest and alchemist Imhotep. Well, his knowledge up to this point enabled him to make small sacred vessels which looked exactly as if they'd been made from natural stone. It was quite an achievement, but he still had a long way to go before finding out how to build an eternal abode for his god, a permanent towering monument of stone, which for the Egyptians was the symbol of eternity.
He intuitively knew the answer was in reproducing the mineral binder used by nature to glue together shells and the remains of marine organisms into very hard rocks that could withstand immense pressures, intense sun and hard rain during millions of years. Imhotep's researches led him to find at Saqqara 2 different kinds of limestone strata that contain shells and clay. One, which is imperishable, formed into banks of very hard rock, and another one, very soft, could be easily disaggregated under pressure or with water.
On the border of the plateau of Saqqara, we find 2 different types of limestones. The first one is a very hard material which will withstand without any problem sun, rain and pressure. And in between, a very soft material which will be very easily disaggregated and could be the right material in the reagglomeration process of the limestone blocks. When Imhotep applied water to the soft limestone with shells, it easily separated, leaving a clayish mud, and the remains of the shells sank to the bottom.
He now had only to find what substances he should add to re-harden the mud into small blocks that would acquire the same consistency of the other very hard limestone. Imhotep must have experimented with several substances until he mixed limestone mud with caustic soda. That triggered off a reaction of clay with lime, forming a very powerful binder.
Caustic soda is a very aggressive alkali which will attack the clays and transform the clays into a rock which is called a zeolite or feldspathoid.
The same geological glue which in the natural course of things takes thousands or perhaps millions of years to form a stone could now bind together shells and other aggregates and produce the same effect in a matter of 24 hours, plus another 30 days or so to become completely dry. This mixture hardened into a highly resistant block, and Imhotep was finally able to present an artificial stone to his sovereign, the Pharaoh Djoser. It was not very large, but it was a tremendous breakthrough.
Imhotep had invented the arikat, or man-made stone blocks that would be used in building the first pyramid, this one, the step pyramid at Saqqara, designed and brought to completion under his guidance during the reign of Pharaoh Djoser.
The ancient alchemy of Imhotep was eventually lost, only to be reinvented 5,000 years later by the French professor Joseph Davidovits in his laboratory at Saint-Quentin, some miles to the northwest of Paris. Dr. Davidovits was so sure of the formula he had discovered in the Famine Steel on Sahel Island that he set himself the task of fabricating an artificial stone exactly as the high priest Imhotep had done so long ago. His experiment was successful. He then decided to make a stone of the same dimensions as the majority of those found in the Cheops pyramid. Following Imhotep's recipes for cement, Davidovits produced a 2-ton pyramid block.
We have studied these rocks, and either at V scale or in microscopic study, it appears exactly like natural rocks, a fossiliferous limestone.
If Professor Davidovits is correct in surmising that the ancient Egyptians had developed this sophisticated technology, then why was it not handed down to posterity? In the Western world, cement, Portland cement as we call it, was not invented until the early 19th century. How and why was the Egyptian formula lost? We don't know. But it is wrong to suppose that more recent technology and innovations are always necessarily superior to earlier ones. Many scientific discoveries of ancient times were lost and then reinvented.
In the case of ancient Egypt,
The old revolutionary technology employed in building the pyramids was not widely known. It was the exclusive property of a small group of priests and not part of the general Egyptian culture. Therefore, it could easily have been wiped out of memory in the two intermediate periods of internal war and strife that tore Egypt apart, not to mention the successive invasions and the sacking of Egyptian treasures by Ethiopians, Assyrians, Persians, Romans, Nubians and Greeks over thousands of years. Not only was the technique lost, but also there came a time when the Egyptian builders had exhausted mines and quarries, and they no longer had sufficient quantities of the precise materials they needed to work with. Hieroglyphs show how they undertook expeditions in search of the necessary materials. In fact, as we know, they were unable to find them. It is revealing to look at pyramids built in more recent times, that is to say a mere 3,000 years ago, as against the 5,000 years which separate us from the era of Imhotep and later Cheops with his giant pyramid. Pyramid building became far less efficient. In fact, most of those which are not as old as the Step Pyramid or the giant pyramid of Cheops have soft cores made of sand and are encased with limestone facing.
We have here two different types of pyramid construction. On my far back, the pyramid of Djoser, made of manufactured molded limestone blocks, and here the pyramids of the pharaoh Huserkaf from the 5th dynasty, who built his pyramid 100 years after Cheops. It is a simple heap of natural stone, stones which have been taken out of the vicinity directly on the plateau.
When the casing was removed, as often happened when new builders reused the stones for other temples and monuments, the pyramids crumbled away. Their material was not comparable to those enduring stones from which the far more ancient structures were built. In our next program, we will join Pharaoh Djoser and Imhotep in their building of the Step Pyramid. We will also see how Imhotep's formula was perfected by his successors and used in the building of dozens of different pyramids. We will witness how the size of the stone rapidly increased over the pyramid building era, from Imhotep's small blocks weighing a few kilos to enormous blocks and support beams weighing up to hundreds of tons apiece, impossible to hoist and move without wheels.
The theory put forward by Professor Davidovits has not yet been universally accepted by Egyptologists. Many of them continue to propagate the story of thousands of slaves hauling huge stones to the pyramid site and then shifting them by the use of ramps. But if Davidovits is right, and everything seems to indicate that he is, then the consequences are going to be very far-reaching indeed. Egyptology, as we have seen, is a relatively new science. Some would say it's in its infancy. And the least that can be said about Dr. Davidovits' discovery is that it sheds a surprising new light on what must have been going on in Egypt in those remote times. As a result, a great deal of history may well have to be rewritten. And who knows, perhaps further secrets are still lingering here within these mysterious Egyptian stones.